Good afternoon, everyone. Welcome to our Friday webinar. Today, we're going to be introducing you to custom tables. By the end of this video, you should have a greater understanding of how custom tables work. Specifically, we're going to be looking at the LED strip rebate table and how we can modify a copy of that table to make it do something completely different. I suggest watching the video once again once it's on YouTube and following along. Copy what I do. This way you'll have a cool new table for your CabMaster and you'll have a greater understanding of how your other tables work, and you can start creating your own custom tables. Today, we're going to be using CabMaster Pro V12. It's being drip fed out to all customers with active customer care at the moment. If you don't have the update showing already, it won't be far off. Some things we're going to look at today include what are custom tables, how to apply custom tables, what are local properties, how does the LED strip rebate reference the local properties, how does the LED strip rebate work? So we're probably going to cover what the LED strip rebate is. And how can I create a new custom table based on an existing one? As custom tables are nearly limitless in what we can add and do with them, we won't be answering questions today. We are going to be looking at more custom tables next week and have some other webinars for custom tables planned. You can leave the webinar at any time by clicking on the red phone button at the bottom of the screen. If you do have to leave the webinar early, this video will be uploaded to YouTube within the week, so you can always catch it there. So we'll start with what are custom tables? Custom tables provide information for machining, much the same as draw tables. The difference is that custom tables can perform tasks as simple as adding a 10mm hole, 50mm in from one edge and 50mm in from the top, through to something as complicated as adding machining for bifold doors. Writing basic custom tables doesn't take too much knowledge. You should be able to write your own by the end of this video. Because there is no limit to what formulas can be used and what combinations, there's always something new to learn, and there's no one that knows absolutely everything there is to know about custom tables. Now, if you think of a custom table like a spreadsheet, cells in a row can reference other cells in that same row. They can hold values, they can contain formulas. You can mix codes from CabMaster into formulas. You can do all sorts of amazing things with them. They then apply the machining in that row to the cabinet you're applying that custom table to, or the part that you're applying that custom table to. And that is all done through the interface in the custom tables. So if we open up a cabinet and go to cabinet machining, you'll find all your custom tables. You can apply them to different parts and select different custom tables and turn them on. So let's start with how do we apply custom tables? For any single cabinet, go to cabinet machining and then custom, which is what we've done. So this shows the list of parts that you can apply the custom tables to. Not all the parts of the cabinet can accept custom boring and routing. If you're doing a universal and you have, say, an area 1, lower 1, then you can go into the area 1, lower 1, and then go and apply more custom machining into those additions, like if you're putting drawers in or shelves or a grid or something into your universal. As we're looking at the LED strip rebate today, I'm going to be using a tool, Open, that has been set up for a wardrobe fit out. I want the custom table to apply machining to the top piece of the carcass. So we might put this on 3Y frame, and we'll open that up a bit. We can see that there. So I want an LED strip rebate in the top of the inside of the carcass. So we click on top, it opens up another window, and we can see that we have our custom tables there. I'm going to choose LED strip rebate, which you can see I already have. Turn the tick box on. There it is, which it already was. If I turn it off, it goes away. Apply and OK. If we change our focus to the top of the cabinet, zoom in a bit, we can see that it's applied the rebate to the outside of the carcass. If we're adding crown molding and wanted a moody glow above the cabinet, with, so it glows off the ceiling, this would be perfect. This would be unreal. But we want it to be on the inside so that it lightens up whatever's in our wardrobe. So we need to change the machine face. So we'll close that. Now to change the machine face, we need to go into drawing properties, going to machine general, and go to face. Now we want to change for the tool cabinet, the top of the tool cabinet, we want the machine face to be the bottom because that would be on the inside of the carcass. We can apply and go OK. Open up our cabinet. And if we zoom back in, we can see that our LED strip rebate is now on the inside. Try and get a better image of that. There we go. Our LED strip rebate is now on the inside of our carcass. So the LED strip rebate is positioned based on local properties. So what are local properties? Local properties are fields that can be added to your drawing through the drawing properties. So we'll go back to there. In job setup, local properties. In a default installation of CabMaster version 11.1 or version 12, you should have these three here. They are for the LED strip rebate specifically. If you don't, go to My Setup and then Local Properties, and you can add them in here. Take note of the number next to the checkbox. This is vitally important in getting the custom table to reference the corresponding local property. So if we turn on number 7, we tick that box. We can see that it's highlighted X7 there, so we could actually modify that to something else if we wanted to. Tick that back on. Go back to job setup. In local properties, you see that we now have the X7 there and a field that we can enter information. So for now, I'm going to put in 12 millimeters, and you'll see why I've done that later on. If I needed to make a change to the local properties permanently for all future drawings, you just go to File, Prepare, Catalog Properties, make sure you've only got one drawing open, click Proceed. It's all much the same as drawing properties, it's just pink. Once you've done that, make sure you apply OK. When you close down the drawing, it'll ask you if you want to save the drawing. It will then also ask you if you want to save the catalog. So let's go back to drawing properties, and F4, perfect. And we'll discuss what changes what. It's all reasonably self-explanatory. Distance from the back being 50 mil, that's from the back of the carcass. It's from the back of the carcass to the back of the LED strip rebate. Width of rebate, pretty straightforward. It's the width of your rebate. And then depth, again, is depth of rebate. There's nothing unusual or out of the ordinary there. What we'll cover now is how the LED strip rebate table references the local properties. If you've been using CabMaster for a while, you've probably noticed the little pop-ups that show some code or information when you hover your fields over the drawing properties. For example, I can show you what that looks like. If you hover over this one, we can see that it says enter a string in the edit box for defin 1. That one will be defin 2. That one's defin 3. Because this was number 7, this one you'll see is 7. So those numbers correspond with the numbers that were here. So we'll locate the custom table folder through File Explorer. And to find where our custom tables are saved into, go to File and then Options and go to File Locations. That's the folder location that our custom tables are saved into. So you can copy and paste that into File Explorer. I have already gone ahead and done that. So it'll be in Tables, then going to Machining and Custom. And there is our LED strip rebate right there. If we click on that and go open with table editor.exe, if it doesn't have this logo here, you might have to go choose another app and go searching for it. You'll find the table editor itself down here somewhere. It's all in alphabetical order, so you'd think it'd be down the bottom. There it is there. And you'd go open with table editor. So right click, open with table editor exe. And this is the table that will pop up. It will always pop up on your default main screen. So if you're running 3 or 4 screens, it will go to your screen number 1, which is why it popped up off screen for you guys. So this is the table that holds information for the machining of the LED rebate we've been looking at. At first glance, it looks reasonably complicated. It is only one line and it is actually really, really simple. Lines 7, 8, and 9 are showing us the parameters of this table. Deleting these won't affect machining at all. They are just there as a guide for users. Line 11 is where all the magic happens. In the depth column of line 11, we have point 10.z, that there. This is referencing a column called Z10 at the far right of the table. If we scroll across, we can see it here. That is defin 3. So this is where it's referencing the local properties. So if we go back over to the left-hand side and the bulk of all the information, we know that point 10.z is defin 3. We can see that point 10.x is defin 1. Point 10.x is defin 1. So point 10.y would be defin 2. So while we're here, we might type it in here. Point 10 dot. That was x. Point 10 dot. Of course, these don't have the brackets around it, so you probably should do that. And I will do that to make sure it's correct. Point 10.z. Hopefully that all makes sense. I've written that wrong. Now, getting these codes is absolutely vital or things won't work. It's very easy to miss something if you have edited a custom table and it doesn't seem to be working, or if you've followed this step along after watching the video, it doesn't appear to be working. Just go back and check your codes and make sure that you haven't mistyped something or put the wrong value in the wrong row. So I'm going to immediately save that so we know what it is. Okay, so if we look over here, we'll see that there's other codes, code in Y. There are a couple of formulas that are made up of multiple codes. So we'll have a look at what they do. We'll close that. And we'll go cancel. And that is just there, distance from back to fin 1 point X, Y, and Z. Now, how does the AEST strip rebate table work? If we view the top machining of that cabinet, so we can see that, and we'll click on there, go to machining, and we'll click on our top. And then we open up our table again. We can start plotting our points and seeing what does what. So we'll open that up and we'll go back to CabMaster. So what we're going to do is look at the lines and work out what each point of this AEST strip rebate, which is this one here, is doing. So in our table, we're going to look at line 11. We know the depth is to fin 3. Okay, so to make it a bit easier to understand, in this situation, the X column is your left to right, and your Y column is up and down. So the first X and Y column is 0.1. So it's going to be the first point in this shape. It could be, or in this little rectangle here, it could be any 4 of those corners, but we can actually look at the table and see which one it is. Of course, then X2 and Y2 will be the next point or the next corner. X3, Y3 would be the next corner, and X4, Y4 would be the next corner after that. Now, if it's a 4-cornered shape, so a square rectangle, you'll also have a 5th corner, which will be identical to your first corner. And that's just because the shape needs to be closed in order to machine correctly. So if we look at our table, we can see that our X is -5. So that's 5 mil left of our far edge. So if this point here was 0, 0, -5 would be out this way. So we know it's going to be one of these 2 points. Then our Y column for 0.1 is code in Y minus 0.10.x. So that's the one that has to fin 1. So codim is the width of the part or the height of the part. So codim Y would be over here. Codim X is here. So we've got codim Y minus 0.10.x, which is minus the distance from the back. So there's our codim Y minus our distance from the back, so that we know we're working with this corner here. If we know that 0.10.x is referring to column X10, that one there. Then code in must be referring to the height of the part, which we already know. There's only 1 point on the AEST strip rebate that matches, and that is that top corner. We've been over that. So point 2, we should be able to look at that and work out where it is. So it's x2, y2. So you'll see that x2 is codim x plus 5. So we know that codim x is the width of our part. So that this line here would be codim x plus 5. So we're extending past. So we're going to be over this side. And then we have this value here, which is 0.1y. It's referencing our y column, our first y point. So it's actually saying that and that. I could copy and paste that into there. It'll do the exact same thing. So we know that it's the same distance from the back. So it has to be that point. So now we know that this table is being drawn in a clockwise direction. So if we look at point 3 there, in y3, we'd expect the x3 to be the same, which you can see it is, and then the y3 is point 2, which is this point here, minus 0.10.y, which is our defin 2, and defin 2 is the width of the channel. Point 4, which is x4 and y4, we're back to that negative 5 mil. So we're back under 0.1, or the same distance from the left as 0.1. And then y is 0.3, and our 0.3 would be y3, that one there, this column here. And then, of course, x5 and y5, they could both be, this one could read 0.1.x, and that one could read 0.1.y, or it could read negative 5 mil, and that could have the same code as that there. Essentially, as long as if it's a 4-corner part or 4-corner cutout, rebate, whatever you want to do with the custom table, you have 5 points to close the shape. So I'm hoping all that makes sense. You'll see some columns have, or some said columns have got a 0 value in them. This is simply the radius of the edge between the corners. We're not going to cover this today. You'll also see some columns in with rep in them. These two here. Don't worry about them today either. Just know that rep quantity needs to be set as 1. Now we know how to change the positioning of corners, or locate the positioning of corners. We can alter the codes and formulas to change the direction of our rebate. So I'm going to close that. I'm not going to save it. So how can I create something similar to the LED strip rebate? I want it to run vertically in the ends of my carcass, but they need to stop above the first fixed shelf. So if I open it up, I want them to run vertically here, but I want them to stop around here somewhere, so they're sitting above my first fixed shelf. You can see my shelf holes there. And that's why I'm going to use defin 7. So defin 7, if we go to cabinet details, we can also change that at cabinet level here. I'm going to set defin 7 so it is the distance from here to the bottom of our rebate. So it's exactly the same as the distance from the back of the rebate. It's just coming from another edge. So the first thing I'm going to do is make a copy of our LED strip rebate. And the reason for that is, if I make any mistakes, I can always go back and just get the original. And we're going to rename that, and we'll call it something like AEST rebate, end short. So back in CabMaster, if we go to cabinet machining and we apply our custom table to our left end, we'll call it, where is it? Oh, it is strip rebate, end short, there it is. Apply and OK. We can see that it runs left to right, which is not what we want. So all we need to do is change the direction. Oh, that's the first thing we need to do. So open up our newly created table, and I'm going to move 0.1. So our X and Y column to be 5 mil above the top of the part and 50 mil from the back edge to match the local properties. So if I close that down, this is essentially what I want to do. That's going to be 0.1, 0.2, 0.3, 0.4. You see defin 7 is there, defin 2 is there. 0, 0 is that corner down there. Go back to here. So the Y column, we want it to be above. So we're going to go codim. Again, this is another example of why you need to get things correct. Codim Y plus 5 millimeters. So I'm telling it to be the height of the part and extend 5 millimeters. The reason we extend 5 millimeters past the edges is so that it doesn't have the radius of the tool when it cuts out the rebate. And then the X is going to be the X column will be codim X plus 0.10.x, and I'll explain that in a second. So we've got codim X plus we'll double check this, codim X plus point. We'll go 10, close that off, dot X. So we're the width of the part plus 0.10.x, which is the distance from the back. Now, I think I have entered that incorrectly, because what's that saying is it's going the width of the part. So if this was our end, the width of our part plus, so it'll end up over here. So we actually need to go minus. That was a lucky mistake. Codim X minus 0.10.x. Now you'll see that it has little quotations on either side. That is because up here we have this set as none. Click on that, change it to string, and they will go away. So point X5 and Y5, they're going to be the same as point 1 and point Y. And the easiest way to do this is by both making them 0.1.x and 0.1.y respectively. Now that has gone to error because, again, up here we need to change that to string, and we'll need to type that in again. 0.1.x. If we double click up here, it'll change the width of the column to fit. So that's our first, that's our start point and finish point sorted. Now let's look at column X2. So X2 is going to be this point down here. Remember, we're working a clockwise direction. So X2 should match the first X column. So we can put in 0.1, 0.1.x. Y2 will be the distance from the bottom that is determined by defin 7. We could simply put in here, it'll be defin 7, and that's because it's working from the 0 point upwards. If it was working from the top down, it would be codim y minus defin 7. But because it's working from the bottom, we could just put in defin 7, and that would work. To keep the order or keep consistency in the table, I'm going to put defin 7 over here. And then I'm going to change that to string. This is vitally important. Keep an eye on those column types. I'm going to go into here and I'm going to go dist from bottom, defin 7, and that will be 0.9.y. That is it over there. 0.9.y. Hopefully this is all making sense so far. So back over here in our Y2, we could put in point Y inside 0.9.y. Make sure the numbers are inside the brackets so it works properly. The third corner, this point here, which is our X3 and Y3, should have the same Y value as 0.2 because it's the same height from the bottom. So we can copy that and paste that in there. The X value is going to be the same as 0.2 minus the width of the LED rebate. So we can use 0.2.x minus defin 2. And that would work. But then we can replace defin 2 with 0.10.y because that's what we have over here. .10.y. The fourth corner is going to be the same X value as 0.3. And it's going to have the same Y value as 0.5 and 0.1. So fortunately, we've already got 0.3.y in there, except it needs to be changed because it's the Y column to 0.1. And in our X, because it's the same as 0.3, we can go 0.3.x and make sure that is set as string. So we'll have to retype that. 0.3.x. So we'll save and close that. . we'll open up a cabinet, and then we will apply something else. So we'll go for corner, and then we'll go back to end short, apply and OK. And that isn't updating. Perhaps we need to go to FNF4, go down to hardware or materials managed. We may even need to refresh the entire drawing. Click refresh on there. There we go. So there's our AEST strip rebate, and we'll see if we zoom in and I click on that corner, we can see that it's 8 mil, which is the depth, and it's 12 mil up from the bottom. This is only going to work correctly in the left end though. If we look at it in the right end, and turn it on, and then view end right, we can see that it puts in the same place. But if this is the back of our carcass, then it isn't going to work, and we can view that in a 3D wireframe. You can see it doesn't line up. So what we're going to do is go back to our table, open that up, open up our AEST rebate short, which is our new custom table. Now you can duplicate lines. The safest thing to do, honestly, in my opinion, is copy and paste the lines above. The reason for this is that you can see exactly what you're doing, and you know if you're going to do something wrong or make an error. The possibility or the risk of duplicating a line is that you may accidentally replace a line that's already there, or if you're using a line or row number that already exists, it won't work at all. So we'll paste all that in, and everything needs to just be absolutely identical at this stage. We made a mistake there. We need to change that to fin 2. Tab, Control C, Control V, Control C, Control V. Perfect. And for now, as an example, I'm going to leave that as 0. Now, what we need to do is change our X values, because that's our left and right values, so that they aren't calculating off the total width of the part, but instead calculating from 0, 0. We close that down. So instead of our X values calculating from here back, they're calculating from here forward for our right end. The simple way to do this is by removing the codim X in the X column, and we'll do that only in line 12 because that's the only one we want to alter. Because we set up the other columns to reference based on the first one, we don't have to go through and alter a heap of cells. If I save and close that, we'll turn this on. So 1 is on, 0 is off. File, save, close, back to here. F5 on the keyboard will refresh the drawing. So that's, if you don't have a whole lot in your drawing, it's another way of going about it. And you can see now there's both our LED strip rebates. What you will notice is this one isn't 50 mil from there to there. It's actually 32 mil, because it will be 50 mil to the front of our LED strip rebate. So if we go back to our custom table, and I'll drag that over. If we look at our X3 point, so it's currently 0.2 minus the width of the channel. So it would now need to be plus the width of our channel. And of course, X4 would be the same, but we don't need to do that because it's already referencing number 3. We'll save, we'll close that, quickly refresh. Yes, and we can see that our AEST rebate moves. So we only want the one to show on the left hand and then the other one to show on the right hand. So that would be line 11, which is our first one, or row 11 to show on the left hand and row 12 to show on the right hand. The use column is what will control this. Again, 0 is off, 1 is on. We can enter formulas here to say if a particular part, or if it is a particular part, be on, otherwise be off. So we first need to change this column to be a string so that we can enter formulas in there. And in line 11, the easiest way to write this out would be if, use a bracket, sec part name equals ENL, close bracket, then 1 else. Again, all this absolutely matters as far as spelling goes. There are other ways you can type in these codes. This is just one that is very clear and easy to read. It's if section part name is end left, then on, otherwise off. So this one here, and copy and paste that, change that to R, replace the L with an R, and we can save that. So this one is if the section part name is end right, then 1, otherwise 0. Close that down, back to here, FN F5, which will refresh, and there we go, 1 disappears. If we go and look at our right end, you can see that it's now at the back. So if we look at it in 3D wireframe, there they are there. So now if we go into cabinet details, we can either do this at the drawing property level, and that is FNF4. I need to close that one down first. And go to job setup, local properties. We could set this in here to something like 650. I would recommend putting millimeters in there. It is worth noting you can also put formulas and other references in here. So I could type defin1 into this one here, and it would use that value there for defin7. I'm not sure if I applied that or not. We'll go back and check. I did. Now, the reason it's not updating in this cabinet is because I have probably altered it at a cabinet level, which I have. Once you alter this cabinet level, we'll click reset, see if that does it. No, it doesn't. Once you alter your local properties at a cabinet level, they're going to stay that way, so we'd have to alter it here as well. Apply that and we can go OK. And we can see there is our AEST rebates. They stop short. I can go in here, I could set that as, say, the depth of our carcass, which is 560 minus, I want the 50 mil from the front. Press tab, apply it, okay. My carcass is only 480, so that's why that didn't work. 480. And there you go. Now we'd have our LED strip rebates around the inside of our carcass, and I could apply them to many cupboards throughout, say, a walk-in wardrobe, anything like that. And then, of course, we can turn them on and off. If I wanted to apply it to another cupboard, we'll grab another one from here. We'll go for tool open. It's going to be here somewhere. Tool open, drop that in there. Press escape. We will remove our shelves. Then go cabinet machining, custom, end left, and we'll use a new table. We'll turn that on. Now you can see it's automatically using the 650 and the 50 mil back from the local properties set in the drawing properties. We'll turn that one there on as well, and short. Now these can be automated through system properties. We're not going to go into that today. That's a whole nother level of table complication. We'll turn on the top as well. You'd notice that if we applied this table to the top, it wouldn't work at all because we're telling it that it only works in an end left or an end right. So it also wouldn't work in divisions. You would need another line to say if it's a division left or division right. You could also alter that first code to say if it's a end left or a division left, then on, else off. So go LED strip rebate, there, apply, okay. We can see that's it there. Let's go to our drone properties, set that as 16, so the thickness of our bottom, and the distance from the back, we're going to set as 350. And in this case, I have a 12 mil deep channel. It is always worth putting millimeters on the end or whatever unit you're using. If you're in America or Canada and using inches, you can put in, I'm not sure what you call these, the comma or anyway, you know what you're talking about. I could put those in the metric CabMaster and it would automatically change things over to feet and inches. There we go. There's our channels. Let's look at our machining for one last time of our end right. We'll zoom in. We'll click on an edge from there to there. Open that up. Now we can see down here that it is 12 mil deep. The layer is LED rebate, and it goes from 350 to 368. So we know that it is 18 mil wide. And the last thing we'll quickly look at is the layer is LED rebate, which is what AEST or NRoute read. And that's the layer in there. You can type anything in there as long as it's within the quotations. It will export that to AEST or NRoute. So hopefully that all makes sense. Writing custom tables if you've already got other custom tables to reference off, is reasonably easy. You can go in here and go, well, this daisy catch table does something similar to what I want. I can go in here and you see this is where I've got the sec part name equals n left. So it's not necessarily that we have a big list of codes that can do everything or formulas that can do everything. Sometimes it is go and find a table that already does something similar to what you want, open it up, look at it, and just break it down. So this is basically saying if the door is hinged on the right and the section part name is on the left, so it's the left end of a cabinet that has a door hinged on the right, then on, else off. A lot of these custom tables they can get wildly complicated. For example, the Wingline 770 double cup, we can have all that information just in whether it's being turned on or off. And then we can have these big, long, complicated formulas just to set positions. Again, once you start breaking formulas down to seeing what they actually do, it is all reasonably straightforward. Again, we're not doing questions today because custom tables is just a massive field, and I'm not going to get to all the possible questions you could possibly have. Next week, we're going to be looking at writing a custom table that can add boring or a hole. So say like a lock, a hole for a lock, or a vent, something like that. An actual boring rather than a routing line. So I hope you've all learned something today. Enjoy your weekend. Thank you for spending the time watching these videos. We appreciate it.